Welcome to our virtual talk series, where we engage experts about trends in science, engineering, and education with a simple question. What is the next big thing in your area of expertise? Today, we are hosting Onur Kılıç, an inventor, entrepreneur, and scientist who mentors engineers and medical students. What's the next big thing in innovation or innovative thinking?
First, let's talk about the drivers of innovative thinking. We like to think that humans are innovative by nature, but most of the last 5,000 years, the span of recorded history paints a different picture. A stagnant species that almost seems to prefer not to innovate despite the potential being there. You can't explain this away by saying necessity is the mother of invention or laziness is the father of invention, because looking at a lot of the inventions of the past few centuries, the need was always there, always, way before they happened. People just didn't start to innovate for some reason. And need and incentives matter no doubt for continued innovation, but why didn't we just start to innovate? Despite all the low-hanging fruit pretty much hitting our faces for millennia. A well-known example, the flying shuttle, one of the most important inventions of the early Industrial Revolution, which transformed the textile industry. Shuttle is a wooden piece that a weaver would pass through threads by hand when making a fabric, a method that had been in use for thousands of years by countless weavers. John Kay, the inventor, just added a few pieces of wood to the shuttle so that it could now be kicked from side to side at great speed, drastically improving productivity and allowing the mechanization of weaving. So even for very simple stuff that required no special skill or a scientific breakthrough, innovation didn't happen for a long time. It almost seems like the urge to maintain the status quo is a stronger aspect of human nature compared to the urge to innovate. Even George Washington in his deathbed is rumored to have cautioned against innovation in politics. People don't accept change very well. A writer from Washington's era, Arthur Young, describes it as the dronish indifference that enchains men in the exact paths of their forefathers. Which is understandable, because sticking with what worked in the past is a safer option than change, which can mean uncharted waters, having to face the unknown. And who else to better express this than H.P. Lovecraft?
Of course.
The oldest and strongest emotion of mankind is fear, and the oldest and strongest kind of fear is fear of the unknown. Before you can even think of innovating, you need a mindset that can face this fear of the unknown. You need a growth mindset. So what's that? You know how people say, I want to discover my passion? That's the exact opposite of a growth mindset. That's what psychologists call a fixed mindset. The belief in inherent interest as opposed to those that are developed. It's reassuring yourself that your interests, your talents are there all along, just waiting to be revealed. It's like searching for your one true love. This type of thinking can't tolerate that the innovation process is oftentimes involves unknown incremental steps with many setbacks. Because at the end it implies that once an idea resonates, pursuing it should be easy. Growth mindset, on the other hand, is about the belief that spark of interest, that talent and creative thinking can be cultivated through effort, through persistence. It's about developing your passion even when faced with unknowns, with major difficulties along the way, just like how actual love works in the real world. There was a recent study 2 years ago from Yale and Stanford that demonstrates as well. In the study, researchers first engaged students with several tests to understand if they have more of a fixed mindset or a growth mindset. And these are students from all types of backgrounds and interests: science, technology, art, literature. The researchers then showed them an engaging video. I think it was about the origins of the universe, and most are fascinated. But afterwards, when the students have to read a demanding technical text on the same topic, mindset comes into play. And even the artsy, fuzzy types with a growth mindset are more inclined to read through the text compared to the science techie types with a fixed mindset. So no matter what background, a growth mindset makes you more open to different ideas, even if it makes you uncomfortable or challenges your preconceived interests. It promotes innovative thinking, breaking the mold, status quo. Now back to Arthur Young's quote about how people are enchained in the exact paths of their ancestors. It actually continues with, in what path of life can a man be found that will not animate his pursuit from seeing the steam engine of what? Which is an eye-opener that inspiration is the key here. For example, John Kay had a terrible life after he invented the flying shuttle, but what others saw was that one guy and his simple invention could affect a huge technological leap forward, and throughout the next few decades, people were inspired by this, which turned into a competition to come up with new inventions that completely transformed the textile industry and then eventually led to the Industrial Revolution. So innovation is like an idea whose time has come. It's a mindset, a growth mindset that emerges and propagates within a community and which can also die off if it doesn't reach the critical mass. Pretty much like a virus which meets the right environment. And who's the patient zero in all this? The one who inspires this mindset that drives people to break free from the preferred stagnant state? It's the unconventional individual. Which brings us to your question. What's the next big thing in innovation?
Or innovative thinking?
Return of the polymath. Or let's call it the resurgence of the Renaissance man and woman.
Renaissance man? Like Da Vinci?
Exactly. When we look into the past, we see that scholars were very multidisciplinary. These polymaths or Renaissance men and women had mastery over a significant number of skills. They could draw on complex bodies of knowledge to solve specific problems. To be clear, we are talking about profound proficiency, not simply having broad interest or a Wikipedia addiction. Take Leonardo da Vinci, for example. Besides being a talented artist, he was also a brilliant engineer and a meticulous anatomist, making important contributions to physiology. He would routinely blend engineering and medical principles in his art and vice versa. For example, his contributions to physiology were often inspired by his artistic interests, which then led to various inventions. When he dissected the trachea, it was also his interest in music that drove him, and what he saw was inspiration for the engineering of new musical instruments. He investigated physiology of breathing from an engineering perspective, and that enabled him to invent an underwater breathing apparatus, scuba gear. And this multidisciplinary thinking was pretty much how brilliant people operated in the past. But over time, as disciplines became more advanced, people became more specialized. As a necessity, because there was just so much more to learn and information was flowing in from all over the world. Specialization has its benefits, of course. Quite an understatement. Actually, much of the prosperity our world enjoys today, our technological development, comes from the productivity gains of dividing complex work into smaller specific tasks performed by specialists. But intense specialization also raised barriers between disciplines. So much so that there were many times duplication of efforts where people reinvented the wheel over and over and over again. My favorite example about this is a funny case from the 90s when a doctor in the US published a paper about finding the area under a curve in a medical chart, which turns out is a simple integration method that had been in use for centuries. Hyper-specialization basically drove the doctor to reinvent calculus. Lately, though, there has been a shift to multidisciplinary thinking, to an increased emphasis on generalists instead of specialists. And when I say generalist, I don't mean what people call jack of all trades, master of none. If you spread yourself across too many skills that can rarely be combined, you are not a generalist. You just have many hobbies, which is good. But a generalist is someone who can draw information from a broad range of subjects, but still has specialized acceptably well in at least two disciplines and is able to combine them in meaningful ways. And the first step in becoming a generalist is a growth mindset. Again, because the opposite, the idea that your talents are already fully formed, waiting for you, implies that pursuing your interests should be easy. So you are more likely to give up when you encounter inevitable challenges or outright neglect other disciplines. And considering that innovation usually happens by seeing novel connections between fields, as was the case in the invention of Da Vinci, Without a growth mindset, it will be difficult to become a generalist and innovate in this increasingly multidisciplinary world.
What is driving this shift?
Well, you can look at it from two perspectives, because there is a critical need and because we now have the ability to do so. First, why do we need it? The difference between generalists and specialists is very apparent in nature. Specialization improves efficiency, therefore more competition breeds more specialists, and nature is a very competitive environment. That's why most species specialize for particular ecological niches. They are masters of their respective domains. Example, koala. A small number of species are generalists who only do acceptably well in a wider range of niches, like raccoon. So what's the advantage in being a generalist then? When environmental conditions change or change too fast, generalists are able to adapt, while specialists tend to fall victim to extinction. Basically, specialist species innovate themselves into an inflexible evolutionary corner. And that's what we see with companies and R&D teams. Competitive environments drive them towards hyper-specialization, but when there are disruptive changes to the business or research environment, they can't adapt. They become irrelevant, obsolete. And technological change and industry disruption seem to be accelerating, and people and organizations from all over the world are exchanging information much faster thanks to digital information networks. Basically, by accelerating progress, hyper-specialization is becoming a victim of its own success. That's why for many companies and R&D teams, efficiency is not the most valued competitive advantage anymore. It's flexibility, it's agility, it's a growth mindset and the ability to constantly break the mold, so to speak. In today's world, you will quickly fail if you innovate yourself into a corner by going a pure specialist route. So what changed that we are able to take this more generalist approach now? Disciplines have become less complex, and yes, there is now even more to know, but you cannot delegate tedious tasks and know-how thanks to technological advancements. I can imagine humans taking more of an advisory or supervisory role in the future when machines do the bulk of the work. But even today, we have automation, machine learning, AI, smart equipment, natural language programming, 3D printing, open source hardware ecosystems like Arduino and Raspberry Pi. Then there is easier access to information, communication technologies, and collaboration tools that allow you to delegate some of the tasks to hyper-specialized people. You can now delegate a lot at a price, but it makes it possible to stay connected to the ever-evolving bigger picture. And delegation provides opportunities to look beyond your specialization to get inspiration and disruptive ideas.
Any specific examples?
Of course, there are many examples in business, companies big and small, but I want to talk about cases in higher education as it relates to my experience mentoring engineering and medical students. Medical innovation is now needed more than ever. In the last century, we made great progress in addressing major health issues, and now we face a different set of problems. An aging population and all the complex medical issues that come with it, proliferation of drug resistance because microbes are figuring out how to circumvent our simpler weapons and strategies, and emerging diseases and pandemics as a consequence of a world that becomes more interconnected each day, something that has deeply affected all of us this past year, and why we are doing this talk virtually. Essentially, we have dealt with the low-hanging fruit, so to speak, namely healthcare challenges that were easier to address from a technical viewpoint, and now we are facing more difficult problems that require innovative approaches. So how are we going to create the next generation of medical innovators? A handful of universities, Stanford, Duke, Columbia, Illinois, Texas A&M in partnership with Houston Methodist, NMET, and several others are now launching pilot programs that integrate medicine and engineering with a curriculum that focuses on innovation and entrepreneurship, because even if you have a breakthrough innovation in your hands, it has to leave the lab if you really want it to change the world. Although there are variations in the strategy, the overall approach of these programs is to teach engineering and medicine simultaneously. It's important to emphasize that this is an integrated approach to create physician engineers, not to give medical education to an engineer or vice versa. After all, it's not very uncommon to see engineering majors go to medical school. Not all medical students start out with the traditional pre-med major. But dual engineering medical programs are truly unorthodox in many ways, primarily because engineering and medicine have contrasting approaches that can conflict with each other, which could cause problems when practicing either one or the other. For example, engineering education encourages analytical thinking. You need to develop grasping power, problem-solving skills, while in medical education you need to absorb a large amount of information in a limited time, so you need much better memory power and learning skills. In medicine you also learn risk aversion, since it is human health on the line, while in engineering you pretty much always push the limits in your design, so there's always some risk-taking involved. The differences are even more obvious in collaborative efforts when working as a team. Medicine is carried out in an environment that stresses structure, order, and adherence to prescribed methods. Teamwork in medicine is like playing in a symphony orchestra. Everyone in the team is a specialist from a different discipline that has a very specific role to play, like musicians playing a violin, a clarinet, a triangle. And in charge of the team, you have the orchestra's director, the conductor, who is the generalist with wide-ranging expertise, who unifies the specialists, who sets the tempo of the orchestra and ensures cohesion. Take a trauma team, for example. This is a multidisciplinary team that is activated, assembled when a severely injured patient is brought into the hospital. It's made up of a team leader, usually an experienced trauma surgeon, who is the generalist, the orchestra's director. And depending on the injuries, you have several highly specialized people working under the guidance of the team leaders, such as neurosurgeons, orthopedic surgeons, plastic surgeons, and others. You have an airway team, trauma nurses, radiographer, and technical staff. So it's very structured and specialist-focused teamwork. Make no mistake, this is the right way to do things in medicine, because patients who come in with traumatic injuries but are not treated by a trauma team have higher mortality. Teamwork in a multidisciplinary engineering team and innovation team is quite different. Instead of the structured environment of the orchestra, you have something more like a group of musicians improvising. Think of jazz, a jam session. There are musicians still specialized in playing their own instruments, but the whole process is more of a collective effort and improvised. While doing their best with their instrument, they also need to process what others are playing and have knowledge about how the other instruments work and what their limitations are. They also need to accommodate outside contributors, such as self-invited musicians and special guests. This collective improvised effort, everyone serves as a generalist, and you don't see the clear adherence to prescribed methods you see in a team of specialists. And this is really the right setting for innovative engineering. In a sense, engineering and medicine speak entirely different languages, both with respect to language mechanics and the cultures the languages are shaped by. And the idea of physician engineers is an attempt to create bilingual innovators. And it's really not very different than actual bilingualism, and we can draw several analogies between them. So what are the benefits of being bilingual in the context of innovative thinking? The way we think is actually shaped by our spoken language quite a bit. Even humor, in some languages you have to give away the punchline before its time due to how a sentence has to be constructed. So jokes in these languages have found different ways to be funny. The way a language is constructed, its mechanics and cultural aspects place restrictions on how you think. It streamlines your thought process. But when you speak two very differently constructed languages, you're able to take a step back and recognize the limitations the structures of these languages place on your thinking. Learning two languages allows you to look at problems in creative new ways. One area bilinguals excel at is actually conflict inhibition, the ability to overlook rules when attacking a problem, which provides flexibility in your problem-solving skills. Not just conflict inhibition, executive functions in general are taught to be enhanced in bilinguals, because you need to be able to constantly manage the interference of two languages, which also helps with with making more reasonable decisions, because you get the perspective of two different ways of thinking when you have two languages active alongside each other. So by trying to think like an engineer and a physician, you put in extra effort to manage the interference, which allows you to see new connections and provides a setting for innovative thinking. But all this comes at a cost, of course. Bilinguals generally have smaller vocabularies in each language than someone who speaks only one of those languages. And this is basically the price you pay to become a generalist innovator versus a specialist physician or engineer.
And lastly, what will it take for these programs to succeed?
First of all, a major part of the education has to be project-oriented, no question about it. That's how you hone your innovation skills. And let's face it, medical students are extremely busy. Students learning engineering and medicine will be busier. Project-oriented learning is efficient, but beyond that, it involves an ongoing process of reflection and an iterative decision-making process that draws on complex bodies of knowledge, including art and design, even when you work on a medical device. So it gives you an opportunity to think like a polymath, like a bilingual physician engineer, to see connections between different fields, which is important for innovative thinking. Secondly, teamwork should be required, because the lone genius inventor who single-handedly pushes society forward is a thing of the past. Innovation now happens when unconventional individuals from diverse backgrounds come together, challenging each other to inspire and spark breakthrough ideas. And as part of such a team, students should be required to invent something innovative, addressing a clinical problem, because innovation thrives under reasonable constraints and challenges. Finally, I think it makes sense to have an entrepreneurship component to the program, where students are encouraged with mentoring and incentives to take their invention out into the real world so that people can benefit from it. But beyond all these, what good is an innovation program if it doesn't train you to think big? Remember what JFK said when he announced the Moonshot program, and I'm rephrasing here. We choose to go to the moon not because it is easy, but because it is hard. Because a challenge like that will push the best of our energies and skills. Big challenges create passion. The goal of putting a human on the moon, the sheer audacity of it, blew people's minds, and the challenge inspired people in a way that a smaller goal never could. People who are attracted to innovative thinking love a challenge. So it's only fair to provide the opportunity to think big in these programs. I don't want to call it a moonshot approach to train medical innovators, because everything is a moonshot these days and the concept is highly misused, but it's difficult to disagree with the guiding principles of moonshot thinking laid out by the Solve for X project. So what are they? 1. Aim for 10x, not 10%. It may sound counterintuitive, but from an innovation point of view, it is often easier to make something 10 times better than it is to make it 10% better. Because if you try to make something only incrementally better, you're competing with the status quo, with countless people before you who have already pushed something to its limits with tried and true approaches. When your goal is radical improvement at a disruptive level, it unshackles you. It forces you to push away existing assumptions and start over. It forces you to come up with crazy ideas until they don't sound that crazy anymore. Think of AI for diagnostics or gene therapy for disease treatment. This think big approach is still valuable even if you end up with only an incremental improvement that nobody could have thought about before. 2, fall in love with the problem, not the solution. Your invention should address a clinical problem. Always keep in mind that at the end, you want to help patients and make a better, healthier world. The solution, the technology you invent, is not the end game. If you become obsessed or emotionally invested in the invention itself, no matter how cool it looks or sounds, you will shackle yourself back just to another set of assumptions and techniques. Be obsessed with the problem instead, which will make you more open to change your approach or find radically new approaches towards the best possible solution. And 3, fail fast. Failure is not an option. That's the famous tagline of the Apollo 13 film. If your palms are sweaty and you have one shot at landing your spacecraft safely on the moon, I think saying failure is not an option is perfectly justified. But most other times, failure is an option, and depending on how you fail, it will benefit you greatly. Fail fast is the principle here, so that you can use the opportunity to learn and take the next step earlier. The key here is to make contact with the real world, the clinic, early. The people and realities in a real world setting will straight out tell you what's wrong with your invention and give you ideas on how to address it. And it is important to fail like this as early as possible. Get your earliest version of your invention, even if it's in a most embarrassing state, out there into the hands of clinicians so that you can get honest feedback about why this may be a terrible idea. And you will fail a lot. Great innovations take time, especially if you are thinking of something big, a disruptive idea. And that's why it is important to have an entrepreneurship component to these programs, so that you can take the first flutterings of a possibly great idea and give it the time and investment it needs to take wing. And finally, I would like to add that nothing is quite as simple as it's typically portrayed when it comes to the human mind, which also applies to everything I said about innovative thinking. But there is something to be said about thinking big and ambitious goals. You will most likely fail, yes, but in trying to achieve the impossible project, the things you will learn along the way you will have to push your intellectual, creative, and collaborative energies, those will stay with you forever. And that's the type of skill set that will create an innovator out of you.